I am Matt Youngklaus, and my part of the economic case is to talk about low-cost, high-value strategies for reducing embodied carbon in buildings. I am an LCA consultant working in product LCA and whole building lifecycle assessment. I do work with a lot of Fortune 500s in the space on both low carbon building materials and whole buildings. I previously worked at RMI, where I was in their low carbon buildings program. I wanted to start just to kind of reorient us all toward the definition of embodied carbon. I know that other sessions today have likely covered this, but embodied carbon refers to the greenhouse gas emissions associated with the manufacture, transport, installation, maintenance, and disposal of building materials. In this presentation, most of our focus will be on the A1 through A3 emissions, so extraction, transportation, and manufacturing. Embodied carbon is also a really significant problem. I'm sure you've heard many statistics about the urgency of addressing embodied carbon. We're expected to add the equivalent of the square footage of Manhattan every month for the next 24 or so years out to 2050. And for all of that new floor space, about half of the total emissions that will occur from that new construction between now and 2050 will be from embodied carbon. Embodied carbon is that pulse of emissions that occurs at the beginning of a building's life cycle. And that embodied carbon is locked in once it is emitted. So with operational carbon, shown here in blue, or the carbon emissions that have to do with a building's energy consumption and other operations, you can retrofit a building to reduce those emissions after year one of a building's construction if you find opportunities to reduce energy consumption. But in year zero, the upfront embodied carbon emissions are emitted, and you cannot take those back through any means except carbon sequestration. If we retrofit a building after this, those emissions have already been sent into the atmosphere and contributed to global warming. I also, before I dig into the meat of this presentation, wanted to again point out that buildings use a lot of materials, and it can be very overwhelming in performing a whole building life cycle assessment to consider the hundreds of materials and the many different areas that materials are used in buildings. As this group very well knows, most of a building's embodied carbon emissions are attributed to structural materials, usually more than half the emissions, while the building envelope and finishes are also significant contributors to emissions. Most of the information I'll present on today is from two reports from RMI that I've worked on. One was released in 2021, Reducing Embodied Carbon in Buildings, Low-Cost, High-Value Opportunities. You can find that at the link below at the bottom of this slide, and it is available for free online. And a forthcoming report, which will also be free online, is focused on case studies in the economics of low embodied carbon buildings. I'll tell you a bit more about what that report will entail, but we're going to release it imminently by late February or early March. In the first report, we pointed out that the top building material categories have really significant opportunities for low or no cost reductions in embodied carbon emissions. So by optimizing the concrete mix design, not by even reducing the quantity of concrete in buildings, just by picking the best mixes that are available regionally, there's a 14 to 33% opportunity for embodied carbon emissions reduction at no additional cost. For steel, including rebar, but also structural steel, there was a 4 to 10% reduction opportunity, with additional opportunities in insulation, glazing, and finish materials. A low cost premium was considered anything in the 0 to 5% cost premium range. Glazing was the only area where we saw an opportunity to reduce emissions pretty minimally, but with a decent price tag associated with it. These numbers are from 2021, so it is possible that there are other low-cost measures in glazing, for instance, that we did not consider. One key point that I think is a critical takeaway from this report is that at any point in a building's design phase, there are opportunities to reduce embodied carbon emissions. So I think it's clear to many that at the beginning of the design phase, there are more opportunities to exact more change on a building's design without incurring additional costs. So you can focus on whole building design concepts, like using existing buildings, reusing an existing building as opposed to building new. Perhaps there's a building in the locale that could undergo a gut rehab, but you could maintain the structure, some of the facade materials, significantly reducing the amount of embodied carbon needed to construct a building that meets the client's needs. You could consider alternate structural material choices and design more materially efficient structures. So perhaps tightening the bands on the safety factors that are used in design, or coming up with an alternate scenario, perhaps an alternate lateral force resisting system that is less materially intensive than another one. Later in the design process, there are still opportunities for pretty substantial material substitutions. So you might have the opportunity to use carbon sequestering insulation materials that might have a lower R value per inch of material, but at this stage in design, perhaps you can make the walls a little bit thicker and make some small tweaks to the building footprint. Or you could use fast-growing biogenic finish materials like bamboo in place of traditional drywall as a finish material. Then once you're pretty far along in developed design, there are still opportunities in specification. So for instance, most of the savings opportunities that were calculated for the previous slide were from just specifying low embodied carbon concrete mixes based on EPDs for products that were available in the region of those products. So by using tools like EC3 to look at the array of available materials in a region, you can still exact change at this late stage in the game without changing the building's design. I wanted to zoom in a bit on the insulation question because I pointed out that you could use net storing insulation materials. It obviously depends on the use case, but I wanted to show this slide just to show that there's a wide range from net carbon sequestering materials from corkboard insulation down to high net emitting materials like XPS foam board. In some cases, maybe later in the design phase, you might have to choose XPS foam board for a specific use case. But this graph shows us amongst the products that we looked at in this report, there were 2 XPS foam boards, both made by DuPont, with different blowing agents that had dramatically different embodied carbon emissions. You can see the same in this graphic by looking at mineral wool and other materials. So even if you can't use a net carbon sequestering material like cellulose, which is commonly available and on the market, even if you can't use a material like that, you could still pick the best material that's available to you. The first RMI study in 2021 also took a traditionally designed building and compared what was used on the building project and what the best available materials in EC3 in that region were. And for a steel reinforced concrete slab building, we found a 46% reduction in embodied carbon emissions was possible just by specifying the best available materials on the market. Most of those savings came from low carbon concrete and steel. And this was done with little to no cost premium. For a wood frame building, most of the opportunity was in the foundation, where all of the concrete and steel in the building is located and where there are big opportunities to reduce carbon emissions. And for the tilt-up concrete building that we looked at, there was a 19% reduction opportunity. And again, concrete and steel offered the most significant opportunities for reduction without increasing cost. But we found other opportunities in finish materials and insulation materials for this case study. So the 2021 report has more information if you want to dig into our assumptions. The upcoming report we're working on is the working title is Case Studies in the Economics of Low Embodied Carbon Buildings. And this report includes kind of an update on the state of play for codes, policies, and other mechanisms to reduce embodied carbon. And the key thrust of this report is to demonstrate different methods that general contractors, structural engineers, and other practitioners could use to reduce carbon emissions without increasing costs. These case studies were developed with Skanska. So each method is tied to a real world case study and real costs and carbon emissions data from their projects. And these case studies look at adaptive reuse, an evaluation of structural design alternatives, and using embodied carbon as a metric in bid leveling to find low cost, ready mix concrete solutions that are also low carbon emissions and aligning those goals. Just as a teaser of the bid leveling exercise, here's some real data from a couple of bidders. And this case study is for a high-rise multifamily building in the Pacific Northwest. And you could see that bidder 2 here has the lowest cost and the lowest carbon emissions, cost shown on the left in dark blue and carbon emissions on the right in light blue. So there was a clear win-win where the incentives were aligned to choose bidder 2. Of course, Skanska had other goals they evaluated against. Luckily, bidder 2 met their other requirements. That's not always the case, though. There's another case study in that report that shows that sometimes the lowest carbon bidder is not the bidder that you can go with due to other project goals, due to past performance or the backlog between the GC and that ready mix supplier may choose them to look at a different bidder. But the point is, it's important to have this information as another metric in addition to adherence to specs, costs, adherence to other project goals like timeline, and here adding carbon emissions. Another case study focuses on adaptive reuse. And it's important when considering building new versus reuse that the structural components of a commercial office building typically represent, it's a much wider range than this, but often 50 to 80% of a building's total embodied carbon emissions. And reusing a building before deciding to design a new building can significantly reduce emissions from structure, from the building pictured here. It could be from the facade, from saving brick materials. You could potentially save old windows. And in a case study that we look into in our report, the Kincaid building at the University of Washington, there were more opportunities to save building systems like the mechanical systems. So in this case study, again, in our upcoming report, we showed that adaptive reuse, a modernization and renovation project of an existing building, as opposed to demolition and new construction, would result in 48% lower cost, primarily from the structure, which was 100% reused, the brick facade, which was reused but underwent some maintenance, and avoided site work. So they didn't have to clear the site, they didn't have to demolish the existing building, and so forth. And a 60% reduction in A1 through A5 embodied carbon emissions from mostly the structure, the steel and concrete. There were additional emissions reduction opportunities that we couldn't quantify here that are not included in this 60%. And these were difficult to quantify, but a big chunk of the MEP systems were completely reused. There was a lot of work needed on the ducting, but I believe the plumbing system was 100% reused, and a good proportion of the electrical system was directly reused. So this is another great example where low cost and low carbon really come together to provide the best possible outcome. So in summary, I just wanted to point out that there are a lot of examples out there, and our goal in creating these reports was to show opportunities to reduce cost and carbon at the same time. So less does not have to mean more. So less carbon does not have to mean more cost, as we often envision that. When low embodied carbon alternative materials do cost more upfront, sometimes there are other advantages to consider. If you are putting in a mass timber structure and it has a higher first cost than a steel structure, perhaps you can save on finish materials by having the exposed wood elements instead of paying for additional drywall or drop ceiling or other finish materials. Regardless, it's always worth evaluating the cost and carbon holistically, evaluate them together to see what trade-offs make sense and whether some of those trade-offs might be worth it from the client perspective. And finally, the great adage from the energy modeling world, you can't manage what you don't measure. So if this information is overwhelming and this is new to your firm, a great first step is to perform whole building life cycle assessments for each project so you can compare results, even if you can't yet take action with a specific client or within your firm. So take that measurement so you understand the size of the opportunity. But with that, I'd like to say thank you and leave my contact info here. I'd be happy to take any questions at the end. And with that, I'd like to pass it off to Robbie.
Thank you, Matt. Yeah, so I'm going to be kind of taking what Matt was presenting as far as the economic case for structural engineers and their firms. I'll just say caring or quantifying or focusing on embodied carbon. He had really good case studies and examples, and Kelly's going to have some more of those too. Uh, but to zoom out a little bit, I view this slide as, how do you get your firm's leadership, or how do you convey your clients to your clients how important it is for structural engineers to be able to do the things that we're talking about in this presentation today. So, at a basic level, but how do you get hired to do this work, and how do you do more of this work? So as Matt was pointing out, structural systems are a huge portion of the building's embodied carbon. I don't need to tell uh, probably a lot of people in the audience that, but these key decisions are baked in early, and they're largely irreversible. So being able to have a seat at the table early on is an important part of this. We control a lot of these high leverage carbon outcomes. Concrete gets mentioned all the time. That's us as structural engineers. We have direct lines of communication with suppliers and through our material specifications. So we're the person to be having these conversations. We're the teams to be advancing these parts of the industry. Next slide. Thank you. So this is a graphic that we reference quite a bit that just really tries to convey the different impacts, the different carbon reduction opportunities as design professionals, engineers, embodied carbon design professionals, relative to just existing in society. So you might make decisions in your own life relative to transportation, diet, whatever it might be, and that can have a big impact. What we're trying to quantify here is that working on one building and decisions you make through, say reducing the GWP of that building by 13%, it has a 25 times multiplier as far as what you might be able to do as one individual. So as design professionals, we have an outsized impact to make a reduction on carbon emissions. As we all know, we're typically not just working on one project. So if you take those reductions and average it out over a year with different project types, different markets, it has a 250 times multiplier. So these are big impacts we can have by making these reductions that we're talking about today. So as we all know, we live in a VUCA world. This term comes up a lot: volatile, uncertain, complex, and ambiguous. So I'm highlighting that. Next slide, please. Because as structural engineers, we have a unique ability or position to be making an impact on these things. It's not just an incentive, but it's a duty. So we can lead in these decisions. We can make ourselves more relevant. So we can, reduce redesign by having these conversations early. For the examples that Matt was talking about, we can actually inform policy and legislation and lead in that space. If structural engineers or embodied carbon professionals aren't doing it, others will define the rules for us, whether it is policy or code. So being in those conversations is really important. And it also reinforces our core engineering values as far as efficiency, clarity, and durability. These are central to reducing embodied carbon. And again, it's why we should care about it and why we should be working on it. So to ask the basic question, should we get paid for this work? We're doing more work. We're not just sizing beams and columns with the things I'm talking about. Yes, we should get paid for it. It's how we get paid for it is complicated. Kalen Days and Kelly's going to talk about this a little bit with how Walter P. Moore's handled it. Uh, we've presented it as menu of services relative to embodied carbon focus. Is it just a line item in there, kind of included as far as our structural services? Is it something we just do on all projects behind the scenes? Things like filling out databases like SE 2050. What I'm trying to do is point out how you support this extra effort um, from a firm standpoint. There's definite arguments to doing LCAs on all projects, many projects, to have the data necessary to have benchmarks and baselines and make reductions. But I just want to point out that the rigor only matters if we're able to do it early on in a project and impact decisions on a project. So, for Calendar Day at least, it's one thing to do an LCA at the end of a project after it's built, but it's a whole other thing to do one early on and have it inform design decisions and check back against it as the project progresses. So um, it's great to strive to do LCAs on all projects, but that takes time and money. So just making sure that you're doing them on the right projects at the right time. Typical sustainability trajectory. So often in RFPs or RFQs, there's a conversation from ownership where they say sustainability is central to this project. We want this to be the greenest building of this type. It quickly then becomes more of a checklist mentality where that's recognized. And sometimes as there's budgets that are brought into focus and there's cost reductions, that falls by the wayside. Matt's slide showing carbon next to cost is how we should be approaching these decisions, not as a checklist, not as just kind of an afterthought. It should be alongside the dollar amounts. So why it breaks down is often the goals are, again, kind of more checklist focused, and it's not documented at the right time to hammer that point. Having that conversation early, and it shouldn't be done later in design when it's too late. So baking it into design before it's an afterthought. How we can change that is not just have it be a label, nothing against LEED at all, but make it a design input. Have sustainability and embodied carbon reductions be a design input. Again, do it early when you can make the most impact, and have it be a side-by-side comparison at a schematic level as far as you're looking at different systems, different base studies before you even can do a whole building LCA. So to recognize this part of it, a lot of times with embodied carbon work, we found that our clients are not the architect. We might still be working with the architect on the structural scope, but we've been told this on multiple projects that we already have a sustainability consultant. And so there's still is industry confusion about what we can do as structural engineers compared to what others might do with operational carbon and things like that. So being direct from a contractual relationship to owners, to jurisdictions or municipalities, even to general contractors in a few recent cases, is often where this ends up, as opposed to it being an ad service or a line item in the structural proposal to an architect. Some success stories we've had in that arena. I'm going to talk about this in a second, but we did a whole steel stockpile deconstruction material salvage direct to City of Boulder. We're working now on 2 projects within City of Denver that are part of an embodied carbon pilot program that they have. So that again is contract with the city on projects that Calendar also is doing the engineering contracted with architects. Something like Buy Clean Colorado, we found that contractors need assistance in terms of not just gathering EPDs, but understanding them, making sure that things are handled appropriately. So some of the earlier discussions from the presentations around the different policy landscapes, these Buy Clean policies are an opportunity for us to work with the contracting community to advance that. And then lastly, Kalen has had decent success working with groups like the U.S. Forest Service, USDA, and Woodworks as far as doing larger case study efforts that we are then working for those entities to tell a story different than just making an earlier impact on a building. Again, kind of more robust case study focus, like the things Matt was talking about earlier. So this, and I'm happy to answer more questions on this if time allows or in the Q&A later, but Kale and Day worked on it's the largest steel deconstruction project. Of almost 600 pieces were salvaged and reused in projects around the state. Again, we did it working for the city of Boulder. We managed the deconstruction with the demolition contractor, managed the stockpile and pickups, and used it in projects around the state. And it's been a fun opportunity, but again, that was contracting with the city of Boulder on that one. Next one, again, these case studies are all publicly available, but there's a whole case study series that we did with WordWorks and the USDA and Softwood Lumber Board, comparing mass timber at a comparative LCA level with function equivalent other structural systems. So again, this is great to do on projects at an early level to make those decisions, but this was a more robust full LCA comparison with schedule savings, things like that. So this was again working with those entities. So for Kale and Day, it has been a market differentiator where we're able to work in different markets with different clients who are thinking along the same lines. You know, whether or not embodied carbon is defined as a line item in the services or not, we're finding ourselves working with architects and markets that know us from this work. Transparently, we still have sometimes an internal struggle with time and resources. So a structural engineer that might be doing an LCA, it's more of a known estimate of time, known entity for them to be doing billable work in an analysis model, drawing details, whatever it might be. So there's a push and pull there as far as time and resources on projects. Ideal state looking forward is that clients expect carbon to be discussed early on cost and schedule, that we're doing this early on, we're getting paid for it, it's being recognized as what we're bringing to the table, that carbon literacy is a baseline competency, not a specialty, not a special sauce, not a market differentiator. It's something that we're all doing as structural engineers, and that we're trusted advisors in this, that we're evaluating systems not based on dollar amounts, but based on what's best for carbon reduction. Again, policy landscape is evolving. We're seeing more GWP limits out there within building codes, within different incentives. And it comes up so often in recruiting and presentations that the next generation of engineers cares about this. So our firms need to care about it for a lot of reasons. Thank you.
All right. Thanks, Robbie. To close this out with the business case, I'm going to share several projects case studies where we as structural engineers have added significant value to projects through sustainable design at little to no cost to the owner, but also to some financial benefit to us as well. So looking at both sides of the cost equation. The case studies I'm going to review are 3 projects, all in Georgia. The first one in Blank Hospital for Children's Healthcare of Atlanta, where we served as structural engineer of record and as the whole building lifecycle assessment consultant. The next will be the Atlanta Airport South parking deck replacement, where we did not serve as the engineer of record, but were brought on by the airport and the sustainability consultant to perform embodied carbon consulting. And then finally, the Georgia Tech Student Athlete Performance Center, where we served as engineer of record and were able to incorporate salvage steel into the project. So let's dig in. First is the Arthur M. Blank Hospital for Children's Healthcare of Atlanta. This project opened and saw its first patient in September 2024. It was a $1.5 billion project with multiple buildings in a campus setting. In total, there were about 2 million square feet on a 76-acre campus. It's 19 stories with 446 beds. It's largely a concrete frame building with shear walls, but also has composite steel portions as well. It's been certified LEED Silver for healthcare under LEED v4, and it is in fact the largest LEED for healthcare project in the entire world. The project team included Children's, ESA, Page, now Stantec, Brasfield and Gorey, J.E. Dunn, Walter P. Moore, Working Buildings, and many, many more that are not listed here. So let's first focus on the owner and what's important to them. So the owner, of course, is focused on children's health and directing every single dollar they have to providing the best care for children, period. Full stop. That's what they care about, right? So we as structural engineers know that we have a duty to limit our impact on the environment, to reduce embodied carbon, but that also affects the current and future populations. So how do we marry those two goals together to align them? In 2018, we presented these slides to Children's, emphasizing the connection between materials and health, speaking not only to carbon, but to all of the other embodied impacts, including smog. This stuck and it resonated. And they said, yeah, we do care about this, actually. We want you to do a whole building life cycle assessment. We want you to target reductions, and we want the team to find low carbon solutions. So we were hired to do the LCA. We had an ad service for that. And they also want us to focus on first cost and find solutions that would not affect cost and schedule. At the same time, the owner made this a priority for the team. So everyone knew we were going to have to work together to bring subs on board that could help us achieve the goals. So we first tracked our quantities and measured our carbon throughout the entire project. We were tracking quantities, tracking carbon, tracking quantities, tracking carbon, knowing that tracking and lowering quantities meant ultimately lower carbon and lower cost for the project. Next, but we also had to lower the carbon of all of the concrete that we had after structural optimization. So we optimized the concrete as much as we could, but then we knew we had to specify better concrete. So we specified 56-day strengths where possible. We maximized cement replacement with C ash and F ash and slag. We set GWP limits for all the mixes. We used carbon cure. We required EPDs for everything. And we had tons of discussions with producers about switching to Type L as soon as it was market ready in Atlanta, which for us was in August of 2022. We documented all of this on the classes of concrete matrix and set our environmental impacts there, not only GWP, but also smog, since it resonates and acidification. And we had all of this in there at the time of bid. That was really important to keeping costs down, to communicate this to all of the bidders at the very beginning of the project, setting this as an expectation. If you're a structural engineer and you're currently using a class like this one shown here, there's an excellent guide that we worked on the NCSEA Sustainability Committee. Mike Lyons led that effort that will walk you through performance specifying your concrete. Please go check it out. You can find it online easily by Googling NCSEA Sustainable Design Performance-Based Concretes. As mentioned, we got EPDs for everything, every single mix, and several mixes were specifically developed for this project. One of the great responsibilities of working on a large project is that they're needle movers. You can really transform a project with some of these. Some of the lower carbon mixes that were developed specifically for this project would go on to be used on other smaller projects around town. I would see those same mixes show up in years following on other projects. So big projects are just great to do things like that. Try something new on a big project and then see that happen on multiple small projects afterwards. We're going to transform the market on some of these big projects. Our opportunities for carbon reduction were spread all across the project, with large reductions happening in some elements and smaller reductions in others. This is a typical approach for us in a lot of projects to really maximize cement replacement and reduction in items like foundations and columns and walls and other things. But it was spread across the project. Ultimately, we were able to achieve a 12% reduction in global warming potential with no material cost added to the project and no schedule impact. We also had a significant reduction in smog. And as I mentioned, it was LEED v4 for healthcare certified, and we were able to get 3 points under the WBLCA category under LEED version 4. The project has been a huge success in Atlanta, and our team was able to bring solutions not only in efficiency and first cost, but also in carbon and smog savings. I think that ultimately this project shows to you that you don't have to sacrifice one for the other, that we can do both to the benefit of the owner and ourselves as a business. The project, yeah, you can move on, thanks. All right, So the next case study is the Hartsfield-Jackson Atlanta International Airport South Parking Deck Replacement Project. This project will open up this summer. It's a massive project at over $400 million and over 3 million square feet of parking. It's 7 stories with 6,300 parking spaces and is seeking Park Smart certification. The architect is HKS in combination with Fitzgerald Collaborative. The contractor is a joint venture with Holder leading. The structural engineers on this are TT and Sykes. Several years ago, the Atlanta airport decided to make embodied carbon tracking and reduction a focus for them as part of their sustainability program. And during that time, we were brought on board by the airport and the sustainability consultant EcoWorks as part of a portfolio of Atlanta airport projects that we're doing embodied carbon consulting and whole building lifecycle assessment consulting on. And so that's how we got on the project. So the low carbon strategies for this project were, of course, to focus on the concrete. This is a massive post-tension concrete structure with over 120,000 cubic yards of concrete. At one point, they were pouring 4,000 to 5,000 cubic yards of concrete a week. So our strategies included first, education. There were several entities on this one where embodied carbon was a new topic, so we started there. We also specified GWP elements, GWP targets for all elements. We wanted to maximize carbon reduction as much as we could in foundations, columns, walls, and knee walls, the pieces that were less schedule critical. But at the same time, we couldn't get deep reductions without tackling the floors. But the floors are very schedule critical. At 4,000 to 5,000 cubic yards a week, you can imagine that every hour for cycle times was really mattered. They wanted to stress between 18 to 36 hours for every pour. So what we did was we introduced the concept of using maturity meters here to really fine tune what the submitted 1, 2, and 3 day mixes were really hitting in the field. So the maturity meters relate the in-place concrete temperature to in-situ strength of concrete using pre-established maturity curves. With these sensors, you can know what the in-place strength is, typically much more reliably than concrete cylinders. Maturity isn't new, but it's not commonly used in Atlanta. And the hypothesis here was that the heat of hydration of the mass of concrete would lead to likely be able to stress the 2 and 3 day mixes with lower carbon at 18 to 36 hours, much earlier than the typical cylinder breaks may typically show. And that would allow the construction team to utilize 2 or 3 day mixes more often than they normally would. A lot of times they're just going to keep on ordering that 1 day mix because they know it works and they know it's going to hit because that's when the concrete cylinders hit. But using maturity is just a smarter way of predicting the in-place strength. Ultimately, using maturity turned out to be a huge benefit to the project, and the team was able to utilize the 3 day mix the majority of the time, except in the months of January and February, which are the coldest winter months in Atlanta. In fact, the concrete actually finished ahead of when it was originally predicted, all while using 3 day mixes. Ultimately, the team was able to realize a 15% savings in GWP for the project. And it's also relevant to note that the cost of using maturity meters was offset by using mostly 3 day mixes. Those are a cheaper mix than the 1 day mix because the 1 day mix has more cement, and that's what really causes the cost of concrete to be so high. So to me, there were economic wins all around. The project had at least no added material cost and potential savings. There was a savings to schedule. The GWP savings contributed to a Park Smart certification, and then we were also hired to do this as a service. So I think there can be economic wins that also accompany carbon wins. We just need to leverage the low carbon solutions and also sometimes a bit of technology. And then finally, I'll speak to a couple minutes on the Georgia Tech Student Athlete Performance Center. So this will complete in spring 2026. It's just about done here. It's just over 100,000 square feet and 4 stories. The building is largely a composite steel braced frame building, but also incorporates some mass timber as well. The architect is SLAM, the contractor is DPR. We served as structural engineer of record. The demo sub was a Green Circle Demolition, and the steel fabricator is Steel LLC, located here in Atlanta. So built in the northeast corner of the existing Bobby Dodd Stadium, home of the Georgia Tech Yellow Jackets, The construction of this facility required several bays of the framing of the existing stadium to be demolished to make way for the new facility. Our team here at Walter B. Moore saw this and saw that it presented the perfect opportunity to introduce materials circularity to the project, and suggested to the entire team that the existing steel members in the stadium be deconstructed and salvaged for use in the new building. That's how this whole thing started. One of the engineers just looked up and said, hey, we're taking down some of that steel. We need steel. Why don't we just use some of that? And then the journey began from there. That's all there was. So we talked to everybody. There was a lot of collaboration. We created key plans to identify all the pieces of steel to be salvaged, and then identified where these pieces could be used in the new facility on the construction documents. Now, I'll tell you that we were the original engineer of record for the stadium, and we knew exactly what steel was up there. We knew it hadn't been part of a seismic lateral load resisting system, and we could visually see the condition of all of the members. That made some of this a lot easier. The team was on board and worked collaboratively during the entire process. There were a lot of site walks and design sessions that were conducted between representatives from the project team to align site logistics, sequencing, safety, and deconstruction strategies. We also learned a lot in the process. But it was important that as we integrated this as a strategy, that there was no cost and no impact to schedule. And we were able to accomplish that throughout the project. You can see here the steel being pulled out and salvaged. And then on the next slide, yeah, you can see it in the fabricator shop. So the fab shop, as I mentioned, is here in Atlanta. It's just 9 miles from the job site, just across town. And then here are some of the salvaged pieces in place in the building. And then here are some renderings of the various salvage pieces in place. It's kind of difficult to get all the different views of it. There's a lot that are kind of tucked up in the ceiling that you can't quite see very well. But ultimately, 25 tons of steel were salvaged that traveled a total of 18 miles round trip. This steel salvage saved 25,000 kilograms of CO2, equivalent to 60,000 miles driven by a gas vehicle. And of course, we had several other sustainability strategies for the project that reduced carbon in the concrete, introduced mass timber for a portion of the project, and then required transparency throughout. We required and we got EPDs for everything. You can see all those EPDs there. But ultimately, all of this was at no additional cost to the project. The project is now almost complete, and it's become a great story for everybody involved. We did spend a little bit extra time coordinating and managing the salvage process, but I'm also pretty confident that we'll reap significant benefit from telling this story several times over the next couple of years, because it's a great story. I think those are, I think this is a win for everyone. I mean, hopefully you've seen some ways that you can incorporate sustainable design into your projects. Also communicate the value of embodied carbon reduction to owners and clients, and ultimately see a benefit for your firms and your clients. We've been able to, take on whole building lifecycle assessment consulting as an ad service, as well as carbon consulting for different owners and clients. And then also we've gotten some great project stories along the way. And that's all I have.
So thank you all for sharing your great stories here.